Hey guys, hope your Quizlet went well. So this next problem we're going to look at is a continuation of what we just did, but we're going to make it into multiple steps. So we're going to step up what we've been doing. So to do that, what we need to do is first look at the problem at hand. This is number 9. It's on the worksheet that you should have grabbed when you came in, the one that we were working on before the Quizlet. So if you look at number 9, it says find the value of x. So we want to find the value of that variable there. Now, the problem with that is that to do right triangle trig, we need a side, an angle, then another side. So remember your 4 steps. Step 1, identify the angle. So step 1, you need your angle. So if you look at this picture, we actually have 2 angles here. And the reason for that is that we actually have 2 right triangles. We have this right triangle here, and this right triangle here. So what we need to do is we're going to have to actually set up 2 different problems. So let's talk about how we're going to do that. So again, you're still following your same steps. Step 1, identify the angle. Step 2, identify the sides given. So let's just write sides given, make it easy on ourselves. And then step 3, pick your trig function. Step 4, set up and solve. So if we look at this, let's look at, well, we know we want to find x. So let's look at the triangle that has the x in it. Let's look at this blue triangle. So we're given our angle 57, and then the only other piece that we have is this x, and that piece is the hypotenuse. Now, we have another side over here, but that's not part of the blue triangle. So all we have in the blue triangle that our x is in is the angle and the hypotenuse. If we look at SOHCAHTOA, the problem with that is that we need another side, because in SOHCAHTOA we have 2 sides. We have opposite hypotenuse, or opposite and adjacent. The problem is we only have hypotenuse. So we don't know which one of these 2, sine or cosine, to pick from because we need another side. So what we need to do now is we're going to take this and we're going to say, well, we need something else. So maybe this red triangle can help us find that something else that we need. So we're going to come back and we're going to look at the red triangle now. So it says, well, let's just follow our steps again. Identify your angle. So here's an angle in the red triangle. Then the sides given. Well, the only side we're given in the red triangle is this 30. So this, if you look from the 51, that's going to be our opposite side. And what we need to find now is, well, is there any side in this red triangle that can help us with the blue triangle? So some of you probably noticed this middle line right here is the same for both the red and the blue. So if I can find this side in the red, then I'll have another side for the blue, then I'll be able to find the x. So what I want to do is I'm going to find this side length. So I'm going to call that side length y. Since we already have an x in the equation, I'm going to call that y. So that's that side length there. So now, to find y, if you look, we have that opposite side, and y is going to be adjacent to that 51. So that's going to be an adjacent side. Let's see if I can squeeze that in there. So that's going to be an adjacent side. So now for the red triangle, I have an opposite and an adjacent. So now I've gotten my 2 sides. Now I need to pick my trig function. Opposite and adjacent. Let's go up here to SOHCAHTOA. That's opposite hypotenuse, won't work. That's adjacent hypotenuse, won't work. There's the one I need for my red triangle, opposite and adjacent. So we're going to write our equation out. The tangent of the angle, remember angle always goes in there, is equal to the opposite, in this case 30, over the adjacent side, y. Now if you guys remember, if the variable's on the bottom, we're going to divide by that trig function. So we're going to get y is equal to 30 divided by the tangent of 51. Now from here, We just need to put that in the calculator. So let me pull up my calculator here. Let me move it over so I can still see what equation I need to type in. So we're going to type in 30 divided by the tangent of 51. So 30 divided by tangent of 51. Hit enter. And there we go. We got 24.2935. That 5 is going to make that 3 round up to a 4. So we get a final answer for y of 24.294. So y is equal to 24.294. Now, that's my y value. But what we want to find is this x value up here. So now I know this side is 24.294. And if I look in the blue triangle, I now have the hypotenuse, but I also have this 24, which is adjacent to that 57. So now I'm going to go start my steps over again. I have my angle, it's 57. The x is the hypotenuse, that's one of my sides given. The 24.294, what we just found, is an adjacent side. That's my second side given. So I have adjacent and hypotenuse. That's enough to look at my trig functions up here. Which one's adjacent, hypotenuse? Sine doesn't work. Cosine, adjacent, and hypotenuse. So that's what I'm going to use to solve for x. Let's write cosine of our angle here, 57, is equal to the adjacent over the hypotenuse. So adjacent's that value we just found, the 24.294. That's going to be divided by the hypotenuse, which in this case is our unknown x. So now we have this equation. We just have to solve it. Remember, if the variable's in the bottom, you divide by the trig function. So we're going to get x is equal to 24.294 divided by the cosine of 57. From there, we just put that into our calculator. So let's get out the calculator here. Let me move it over so we can see. So we're going to take this, and since I already have this answer in here, if I just hit the divide button, it takes that answer that we have, so we don't actually have to type in that decimal. We can just use the answer that we got and divide that by the cosine of our angle 57. Hit enter, and there's our final answer. So that means that x must be 44.6048, which rounding to the third decimal place is going to give us 44.605. So x is equal to 44.605, and we don't know what units, so I'm just going to write units. And that's it. So, not too bad, right? You're still following the same 4 steps every time, but we have to find one side in the red triangle first, then use that side to find our missing x value. So it's just a multiple step. We're finding this piece and then using that piece to find our x. All right, let's take a look at one more example together. Make sure we got it, and then I'll leave some for you guys to try. So let's take a look at 10. So with this one, we're going to do the same thing. Remember your same 4 steps. Find the angle. Step 2, sides given. Step 3, pick your trig function. And step 4, set up and solve. Alright, so before we get started, let's write down our trig functions so that we have them down we can pick from. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Alright, so if we take a look here, we want to find the value of x. So here's x. We want to find the length of that side. So what we got here then is the right triangle that x is in. And then we want to look at the other right triangle that we're given here. So let's see, maybe we got enough information we just solve for x right off the bat. Let's see. First step, find the angle. So our angle's 32 there. And the side we're given is the hypotenuse. But we don't have any other sides. We don't have this side and we don't have this side. So we don't have any other sides of the triangle. So we can't solve for x. So what we need to do now is switch over to this red triangle and see, well, maybe if I can find that side of the red triangle, then I'll know that side of the green triangle because it's the same side. Then I can solve for x because I'll have another side. So if we can find this side y for the red triangle, then we can figure out what x is for the green. What we're going to do that, follow your steps again. Just follow those same 4 steps. Step 1, find your angle. Well, here's 24. That's my angle. So side y, that's going to be an opposite side. And then 36, my other side that I'm given, is going to be an adjacent side. So I have opposite and adjacent. So I'm going to come up here. Oh, opposite and adjacent. That's the tangent function. So that's what we need to do. We're going to say the tangent of our angle is equal to the opposite y over the adjacent 36. From here to solve this equation, if the variable is on top, you multiply by the trig function. So we get y is equal to 36 times the tangent of 24. From here, it's just a calculator problem. We got to put in 36 times the tangent of 24 in the calculator. So let's go ahead and do that. 36 times the tangent of 24. Hit enter, and we get 16.028. So that's going to be the value of y. 16.028 or 82? 28. Okay. So that is this length here. So we can write that in 16.028. That's that side length. So now that we know that side, we can then see if we can find x for the green triangle. So let's start with our steps again here. Step 1, identify your angle. That's my 32. Step 2, identify our given sides or our found sides. So we found this side to be 16.028. This is going to be an opposite side. And then the hypotenuse, we already said, is x. So what we have is opposite and hypotenuse. So if we come up to our trig functions up here, sine is the opposite over hypotenuse one. So that is the trig function we're going to use. We then say the sine of 32 is equal to the opposite side, that side we found, 16.028, divided by the hypotenuse, x. Now the variable's on the bottom, you have to divide by that trig function, so we're going to get x is equal to 16.028 divided by the sine of 32. Remember, you're dividing by the trig function, not just the 32. So now, again, this is just another calculator problem. Drag the calculator over the way here. So we got to put in 16.028 divided by the sine of 32. 16.028 divided by the sine of 32. From there, we get an answer of 30.24 and then 6, but that 5 after the 6 is going to make that 6 round up to a 7. So we get 30.247. So x is equal to 30.247. That's going to be measured in some unit that we do not know because it wasn't specified. But that's it. So anytime you see these double right triangles together, just remember it's the same thing. You're just going to do basically 2 problems in one. That's all there is to it. All right, so if you need to pause, continue to take a look at this, that's fine. Pause now. If not, I want you guys to give a couple of these problems a try. So I want you to check out 11 and 13. So if you want to pause to check out those 2, go ahead and do that now. And while you're paused, I will put the answers up here. Okay, so here's the answers that you should have got for those two problems. Here's the answer for the first one, number 11, and then here's the answer for number 13. So if you take a look at my work, hopefully you can see the work that I did there. I'm sure Coach Pierce can answer any questions you may have for that. So we got one more thing, just a quick review after this, and we will be done for the day. So you're going to pause, check those out, and then we'll take a look at the review. Okay, so here are our two review questions. Recap and think is what I'm calling this session. So in the first one, really I just want you guys to see if you can explain how you would find the value of x. You don't actually have to find it. I want to know how you would do it. Tell me the process, write it out in words. And then the other one, I want you to think a little bit. If the sine of theta is 12 over 13, what is the cosine of theta? This is going to lead us into our topic for tomorrow. So pause, take a minute to think about it, come back, and we'll talk about it. Okay, so I answered the first one there. I realized as I was writing out my answer that to tell you guys what this line here is called. So this line here is actually called the altitude of a triangle, where it goes from a point to it's a perpendicular line from a vertex to the opposite side, and it makes a right angle. That's called an altitude of a triangle. So anyways, this is my explanation of how I would do that. So take a minute, look over that, pause if you need to go over it. But that's how I would find the value of x. Okay, so let's take a look now at this bottom one. I didn't do this one yet because I really wanted to focus on it and talk about it. So if we read through, it says, if the sine of theta is 12 over 13, what is the cosine of theta? Well, that's kind of a broad question. So what I would do to make it a little easier, first thing I'm going to do is I'm going to draw a right triangle. Because I know this is a right triangle problem because it's dealing with sine and cosine. So what we're going to do is draw a right triangle here. Now it says the sine of theta. So I just got to pick which acute angle do I want to make theta. Generally, I'm going to make this one theta, but it really doesn't matter which one you pick. So if this one's theta, it says the sine of theta is 12 over 13. Now I remember that sine is opposite over hypotenuse. So that means that 12 has to be opposite theta, and that 13 has to be the hypotenuse of this triangle. So does that concept make sense? Because opposite over hypotenuse, and 12 over 13 would then be the opposite over the hypotenuse. Think about it. Hopefully that can click for you there. So theta is my opposite side, so the opposite side's there, that 12. And the hypotenuse is opposite that right angle, the longest side, so that's going to be the 13. Alright, so this triangle, just knowing that the sine of theta is 12 over 13, we're given two sides of the triangle already. Now this next question though says, what is the cosine of theta? Now cosine, I remember to be adjacent over hypotenuse in my SOHCAHTOA. So cosine's that adjacent over hypotenuse. So if I look at this triangle though, I don't have that adjacent side. I don't know what that is, but I do know the 13. Now, in the previous problems, I could find that missing side because I knew this angle, but I also don't know this angle. So I got to find another way to find this missing side. So there's this theorem that you guys have probably done hundreds of times, where if you know two sides of a right triangle, you can find the third side. It has something to do with A, B, and C, where C is always the hypotenuse. So hopefully some of you clicked already. We want to use that Pythagorean theorem. So if you remember that Pythagorean theorem that says that A squared plus B squared equals C squared. So we're taking a blast from the past here. So to solve this, all we're going to do is substitute in those values. So we said A was going to be 12, so that's 12 squared, plus B squared, that's what we don't know, so that's our x squared, is equal to C squared, in this case, 13 squared. Now from here we just solve this, we got to simplify these squares. 12 squared is 144, x squared I can't do anything with, so I'll just bring it down, and 13 squared is 169. Now to continue to solve for x, we got to get x by itself, so we got to get rid of that 144. Track that from both sides. Cancels there. We get x squared is equal to 169 minus 144, and that's going to give us 25. So now to solve this equation for x squared, to get rid of a square, what you do is you take the square root. So if I take the square root on this side, the square and the square root cancel. But if I do that to one side, I have to do it to the other. So the square root of 25 is going to be 5. So that means my missing side length is 5. So now that I know that that missing side is 5, I can come back and say, well, the cosine of theta, which I know is adjacent over hypotenuse, is going to be the adjacent side here, 5, over the hypotenuse, 13. And that is cosine of theta. So we knew two sides because we were given the sine. Then we used Pythagorean theorem to find that third side. And then once we knew that third side, we could say what the cosine of theta was. And that's it. So that's what we're going to be looking at starting out tomorrow. So what I want you guys to do is get some practice on the rest of that worksheet. Try to finish that. Make sure you really got down finding sides. And we'll get started with some new stuff tomorrow. Have a good day, guys.